I can give a couple updates on what we are doing at the Allen while we wait for, I think we need Lucas to join us. So good morning, good afternoon, everyone. So today we want to discuss, I think we want to continue the discussion that we had last week. And I'm hoping that we can finalize some decision on the experimental design for SLAP 2 and perhaps influence the work for the other rigs. In terms of update on this other work, we had done some preliminary work on the NeoPixel targeting plan with Severin. I think at some point it might be worth it we present it here. And we also have a number of discussion on the 2-photon at the Allen Institute to see what's possible in terms of genetic mapping to be able to identify in-between neurons. I can't promise anything yet, but this is something that we have a lot of active discussion internally. Okay. Has Lucas joined us yet or not yet? Okay. So maybe I'll start with a discussion of the experimental design and where we have discussed with Lucas, with Casper and others. So last week we finished with these slides. Let me share this. Where's the presentation view? Okay. And the discussion that we had was related to all of those few options. And the question we're trying to answer is how to control for some of the analysis challenges in the first pilot. And we discussed having multiple ALBA blocks with different orientation presentation as a standard. And the question that we need to answer is whether those ALBA blocks can be broken down into subparts or shorter so that we can have multiple conditions. And this is why today we wanted to have a little more of a power analysis to sort of have some insight about the data. I think the advantage of SLAP 2 is because we are recording for so many inputs in single neurons. It's a good proxy for also the activity around the tissue. And so it's influential into any analysis or experiment we'll do with calcium or NeoPixel imaging later on. So I think this is a really important set of analysis. Okay, Lucas, are you there?
Yeah. Okay, sorry, I was working on the slides.
Yeah, that's fine. Do you wanna take it from there?
Yes, sure. Okay. Let's see. Do you see the Google Slides?
We see a stop sharing button.
I've never seen such a small thing shared. It's like 5 by 800 pixels or something.
The problem is it's in the browser. So it's still the button or
now it's the screen with it's the team screen.
Okay, perfect. I hope it's the browser. So if that's the case, you should see a Google Slides now.
That's right.
Okay, perfect. Great. Yeah, I had some problems with PowerPoint, so I had to switch to this last minute. I hope this doesn't break it.
No.
Okay, so perfect. This is about a statistical analysis of the oddball contextual modulation. So this is really focused on one particular analysis that we have been doing. Nicholas is doing a different analysis in parallel, which we'll probably see next week. So this is really on this contextual modulation part. Just to get you on the same page again, the idea of investigating contextual modulation during oddballs in this way that I will going to show you is something that Jordan Ham was using already in this PNS paper, where the idea is that there's an oddball condition similar to ours, where there's a redundant stimulus and then there's an orientation deviant with a certain probability. And then there's a control paradigm, which is similar to our orientation or direction tuning paradigm, where the same stimulus occurs at random, so in a random sequence. And this is important because then the same stimulus can be observed in different conditions. So either the context is redundant. This is shown here in the oddball paradigm 1. Sorry, in the oddball 2. So this would correspond to the 0 degree orientation in our case. Or it can be deviant. So that would be the 45 and 90 degree stimulus in our case. And here we will talk later about this. There's the possibility of switching the orientation so that actually both types of responses are observable for the same stimulus orientation. Why is that important? Because by having the control and the redundant and deviant all for the same stimulus, we can disentangle orientation tuning or stimulus tuning from the contextual modulation. And that's what has been done in this analysis. So what's shown here is the average response of ROIs. In this case, it's somata. And you can see that the control response is some average response here, but you see that the deviant response is enhanced, so it's stronger, and the redundant one is decreased or depressed. And this is the averages over this simulation period. Okay, so my idea was to use the same analysis and apply that to our data. I'm just showing this analysis because this is what the trial number analysis will investigate on the next slides. So what I found is when I consider responsive ROIs, and that's actually something that was missing last time I presented. There I presented ROIs. Jordan only restricts his analysis to responsive ROIs, which makes sense because there's nothing you can depress if there's no response in the first place, right? So this seems to be actually very important. And in this case, if I do this and look at averages over these responsive ROIs, we also see depression during the oddball block, both for the 0 degree and 45 degree, but not for 90 degree, which is the deviant, or more, let's say, more deviant orientation. So it's actually quite interesting. From this one could conclude that the control, the second control response is actually the same as the first control. It's, however, if one looks a bit more into the data, there are two types of ROIs, if you want ones, that are responsive already in the first orientation tuning block. And I will show you on the next slide that those are actually the ones that are depressed. And then there are others that seem to develop a tuning or a response only later during the experiment. So this is what I want to show you here. If we consider only responsive ROIs that are already responsive during control 1, so already during the first orientation tuning block, there is a response. We see that there's actually much stronger depression for those during the oddball Plus, there's also a strong depression compared to the first, so during the both control conditions. So there seems to be contextual depression, but also long-term depression of these initial responses, so to say. This is also true for 45 degrees to some extent, not so much for the 90 degree. So I find this quite interesting to see that we have this depression, but one really has to look at the response of ROIs during the first control, and there seems to be long and short-term control. Sorry, depression. Okay, this just on the side because I just wanted to highlight here that this can be a very interesting analysis. The question now regarding stimulus design is whether we can do this analysis on fewer trials. What is the requirements to actually differentiate between these different conditions depending on sample size or trial size? So that's what I did. I randomly subsampled the data that we have, essentially repeating this analysis. And here you just see the mean over the stimulus window, averaged over all ROIs, control 1, control 2, and the oddball. This is now again units that are responsive during any of the conditions. So that's why we do not see this depression between first control and second control in this plot. And we can see that, and the shaded area is the standard error of the mean over the different samples. Here we can see that, well, above 20 or let's say 30 trials, we can very well distinguish these different conditions, at least the oddball and the control ones. So 30 trials seems sufficient to distinguish population responses between conditions. One thing you might notice here is that we do not go up to 40. The reason is that during the analysis, I found that the timestamps for some orientation plus condition during some conditions and some orientations, the number of timestamps is not the same. And so the problem is I don't know which of the DFF array, to which timestamps those correspond then. I guess that's motion artifacts that are removed or so. It's not such a big problem if we just average over this window, but if we are really interested in the aligned responses over trials, we cannot use the data, at least how it's for those trials, at least how it's done now. Maybe you can provide some, or we can discuss this point at the end, what's going on there. It's just something that I noticed and I had to throw these trials out essentially. And it's quite some trials. So for some condition and orientation, it's up to
what do you mean by timestamps are missing?
So if you look at the timestamps so there's the DFF, right, which gives you the response, and then there's the timestamps that gives you the time points at which these different responses have been observed. So what I do is then to align them is looking at the start and the end windows that you would expect from the stimulus table. So we know, let's say at time 1000, we have an oddball occurring, and then I go 500 milliseconds in advance, 200 milliseconds before baseline. But from the time step, we would expect a certain number of timestamps that are in this range. But I see that the number of timestamps for some trials is fewer, which means that some seem to be missing. Maybe Jerome, you can comment on that.
I think what might be happening is, you remember, Casper, we have this trial structure in the SLAP2 data, And so every 20 seconds, we have half a seconds of
Yeah,
missing data. And
got it.
if we run the statistic, that's probably what's going on here, is that we're not using the continuous mode.
I understand. I'm just taking a break from implementing the data analysis pipeline for continuous mode to attend this meeting. That should be finished today. So we should be able to start processing the continuous data today. If I understand correctly, I think that's the right interpretation, Jerome, and this should be solved for future experiments.
Great.
Thanks.
Okay, great.
We actually acquire a continuous data 2 weeks ago, Lucas, but we couldn't analyze it because, as Casper mentioned, there is specific dependency on the analysis pipeline that was relying on this trial structure.
Okay. Yeah.
Okay. Yeah.
Okay. So yeah, it's just, I mean, for now, it just means that during this analysis, I have to rely on a number of trials. But yeah, let's see how we get with this. But yeah, great. Then in future, this should be sorted out. Great. Then okay, just a step back. So this was a sample size dependence analysis of a population level analysis. The previous results already hinted that there are interesting differences between ROIs. For example, those that are already responsive at the beginning or at later points during the experiment. So it's definitely also interesting to look at the contextual modulation for individual ROIs. It's something that I've been looking into already. And this is, for example, a case of an ROI that has a significantly different response to a deviant stimulus. So here, the response is strongly enhanced, which then also shows in the later response. So there seems to be a short-term modulation and also long-term adaptation of the response. So there's interesting stuff happening also on the single ROI level. So the question is, how many tries do we need to? Okay, sorry, this is just a spatial map of plotting these mean differences. So we could also, I mean, looking at individual ROIs might be interesting because we can link this to the spatial information and see if there's something going on there, just as a teaser for this analysis. But how can we quantify how discriminable the conditions are for individual ROIs depending on the trial number? And here I was following a suggestion by Sarah, who suggested to use a classification approach where the idea is to classify the condition from the trial response, kind of going the other way around. Because if we can classify the condition based on the trial response have to be also be discriminable or contain different information, so to speak. And the way one can do this, like the most straightforward way, would be to infer the direction here. For example, here the mean of the deviant response is higher than the control. So we could define a threshold here that detects whether the response is higher or lower between this decision threshold. And everything that is above is classified as oddball, and everything that is below is classified as control. And then we can systematically shift this threshold and see how the number of false positives and false negatives of this classification differ. And that's something that is called an ROC curve that plots essentially this false positive rate versus the true positive rate as we vary this decision threshold. And it gives us the area under this curve, gives us a quantity of how well we can actually distinguish or classify these conditions based on the response. So, for example, perfect classifier would immediately jump up here and then stay at a true positive rate at 1 for very low false positive rates. So the area would be almost 1, whereas for random classifier, essentially, we would expect an area of 1/2, and everything in between. I mean, the more, the better, essentially. So here I averaged over all ROIs and trials, and computed this area under the curve. Now, the question is, how does this area under the curve depend on the number of trials that we have available? I wasn't aware of, or I wasn't familiar with this analysis, so I really didn't know what to expect. So I observed something like this: as we increase the number of trials, the area under the ROC curve is actually, if anything, decreasing. I would have expected naively the opposite, that the more trials we have, the better we can discriminate. But in the end, I don't know, maybe there's also a flaw in the analysis. I did this super fast. I don't know, Sarah, if this is something that is completely at odds with what one would expect, but I think in the end, I mean, the discriminability of 2 conditions shouldn't depend on the number of trials ideally, right? It's more a property of the system, and the trials is just kind of how the proportion we see of it. But ideally, what we see shouldn't depend on the number of trials or what we see, like the snippet we see. So I think the way interpreting these curves is that if we have a kind of consistent estimate of this area under the curve, then this is a good sign, because it kind of gives us the hint that we can actually estimate this discriminability based on the number of trials we have available.
Lucas, I think
Yes.
you have a couple questions in the chat, but I
Oh, yes,
noted.
I'm not seeing those.
Yeah, Sarah is saying that what influenced your interpretation is that you did the analysis across all ROI. Is that true?
So yes, it's essentially looking at the classification results averaged over all ROIs, right? But it's still, I mean, we are only using a single ROI to classify the condition. It's just that the classification score is averaged then over all ROIs.
And then Nicola says, by trials, are you referring to the number of stimulus presentation during the oddball block?
Yeah, both. So it's for example, if I compare control and oddball, I allow 10 trials for each condition. So both are subsampled.
I think my interpretation of your plot agree with your assessment, is that with fewer trials, the measurement should be the same. It's just more noisy. And so in your plots, I think it's the error bar that is really important here. How well can you say this is different from chance level? That's my interpretation, but yeah.
Right. Yeah. One note of caution here is that because we only have so few trials available to do this analysis, of course, the decrease in error bars here is also partly due to the fact that with subsampling, let's say 35 trials to, I don't know, if you consider 85% of the trials during the subsampling, it will look very similar to this result. So if we would have 100 trials from the beginning, the error bars might be much higher here. So it's a bit tricky to interpret this.
If you have fewer data points, drawing a line that separates them is easier. So that's intuitively what I think is happening here, but I'm not fully following.
Yeah. I think you're right. There's kind of a low trial number estimation bias here of this our AUC. exactly because of this effect. Yeah. So we might say for our experiments, we would want to be in a regime where we definitely do not have this estimation bias. So essentially when the curve has flattened out, and of course ideally also when the error bars are very small, so that we can be certain we can estimate how well one can discriminate these different conditions. But the standard deviation, I think it's really hard to interpret it right now. Overall, I don't know. It looks like it's not totally bad. So I mean, already with 20 trials or so, we are in the right ballpark. You know, it has for most cases it has flattened out quite well. But yeah, I think we need a few complementary analysis to get a better understanding of how many trials we need, to be honest. So for example, one thing I wanted to do is just looking at the mean and standard deviation that we observe for the ROIs. And I mean, there are some ways to calculate, for example, the number of trials you need to achieve a certain statistical power for a given mean difference compared to the standard deviation. And yeah, essentially looking at how many units we would actually achieve that statistical power with a given number of trials. This is, I think, a complementary analysis that can help. Plus the analysis that Nicolas will show next week. So yeah. Intuitively, I mean, for example, one rule of thumb is that in order to estimate a standard deviation, you need about 30 trials. I guess we shouldn't really go below 30 trials. I think the 40 is the right ballpark, or 50 maybe. But this is really gut feeling. Okay.
I have a question. Do you again mean 30 trials during the oddball block? Is that what you're referring to?
Right.
That is
right.
30 stimulus
So
presentations during the oddball block.
For like a deviant one, yes. In the end, I think for these comparisons, we should really use the same number of trials between the conditions to avoid trial number differences that are caused by differences in trial numbers. So, for example, for this analysis, I also subsampled the standard oddball because it occurs a lot of times, but I only considered it right before the 45-degree oddball to have a comparable sample size. So I think what we are considering here is number of deviant representations during the oddball per stimulus, but that should ideally be the same as the number of times we show that stimulus during the control.
Because I mean that I think Nicholas is right to pointing this out because if we do 30 trials during all of those blocks, we divide the time 3 times more if we apply it because it's repeated. Currently, we're doing 40 orientation, 40 oddball, and 40 orientation. So that's a big gain if we can decrease.
Right. Although, no, I think I don't understand this point. Is it? I mean, it's the same. It's just a factor of, I mean, 25% less, right? Or am I getting
That's right,
something wrong?
but it applies to all blocks. Yes, we would reduce 3 blocks length, not just one.
Yes, yes. So it's really 25%, for example, going from 40 to 30, applied to the entire duration. Yeah.
Yeah.
That's right.
Do you have? Is this fantastic analysis, Lucas? Do you have other slides you were planning to present, or?
Yeah, I was just wanted to just bring up some points for the stimulus design. Do you think that fits now, or should we do that later?
I think we can discuss it now. I feel like this is also already providing a lot of data point to make this discussion more fruitful.
Okay. Yeah, so this was just an older illustration. At some point, it's just to summarize a bit some points. I think you mentioned this already in the beginning, right, Jerome, with the different visual prediction contexts, so changing the standard orientation. That's essentially what's meant here, that the deviant here shown in violet should be changed. The standard should be changed so that one of these orientations becomes the deviant and standard in the other oddball block. What I want to ask here, what are the considerations for choosing these orientations? Because you could see that quite clearly also in the plots I was showing in the beginning, that what we see for 45 degrees is kind of a, let's say, slightly weaker version of the 0-degree effects, partly probably because the orientation is just very close. So I was wondering, is that something we actually want? Is that on purpose, or would we want to have kind of maximum, difference in direction angle to really make these responses as different as possible in terms of direction? I mean, for orientation, it's already a different story again. But this is maybe a question we could also include in the discussion. Yeah, and some minor points was if it would be possible to enforce a minimum amount of repetitions, because the way it's done currently, it's entirely random. And there are a lot of instances where an oddball is like a deviant is directly followed by a deviant, up to I think 3 or 4 deviants in a row that can happen. And I don't know if that's necessary. I mean, we would make the effect of a deviant probably stronger if we enforce a minimum amount of repetitions before the deviant is allowed to occur. It's also, I think, what Jordan does in his paper, to enforce at least 3 repetitions. It's might be a small thing we could include. Yeah, the control for static is a thing. So I don't know if we need a proper orientation tuning block in addition to the direction tuning block. We just show static ratings to have a neutral stimulus there, so to speak. And we might, I mean, I understand that reducing the number of trials of the deviants is an effective way of reducing the experiment duration. But we could also reduce the number of standards, which is comparatively high if we compare to other papers right now. So, for example, here in this paper and in Jordan's paper, it's 1/8 per deviant. And with that, we could also drastically cut the total duration. So I'm just throwing these points in, and then maybe we can pick them up during the discussion. Yeah.
Okay.
That's it.
I think can I follow up on some of his points? But I feel like this is worth discussing. So the minimum of repetition. So these 3 threshold we could implement. I mean, obviously the distribution will be different, but I don't see any reason not to. I think it's a point that also Casper pointed out that at the onset of the experiment, when we start the audible block, the fact that an audible can occur immediately is not helpful. The control for static, So I don't know if that how does that help? How does that help to have static gratings?
So the point is, if we want to do something like this with the static outball. So right now we have the static outball occurring, but we do not have a neutral condition where it
Oh, I
occurs
see.
without any repetitive input. So the question is, what is the response to the static rating without building up the expectation of having motion, for example, or observing a particular orientation beforehand?
Is there one thing that we could do is remove the static oddball from the design, because I feel like all of those analysis are focused on because the static oddball presence is really for the sensory motor mismatch connection where they do alts, and we are not doing this experiment yet, and so I wonder if removing that oddball will just gain us some time. What do you think?
I think that makes sense. If we do not need this response as a control for that later experiment, to have essentially the. By the way, in this experiment, is the mouse allowed to move or not?
They are doing a lot of walking and running.
Yeah. Okay. Yeah. I don't know if it's not needed as a control for that other experiment. I would also vote for taking it out, because right now I wouldn't know. I mean, you can of course compare the different responses for the different deviants, but I have a hard time relating them, because it could just be that this neuron is favoring, or that input is favoring static as opposed to moving input, for example. So I would have a hard time to interpret these results. So yes, I would also agree we should take it out then.
Okay. And your last point, what was it?
Yeah, reduce the number of standards.
That so we made a table in the archive paper where we summarized the statistics for oddball rate, and I think this paper from Jordan's is on the lower end of repeat numbers. Repeating is way more than others. I'm suspecting it's because his study is more related to adaptation effect, right? And so they occur faster. Would you agree?
You mean it's more about the contextual modulation rather than showing these long-term changes? Is that what you mean?
I think the oddball effect that is measured in this paper is stronger because it's a shorter term adaptation. Is my intuition.
Yeah.
And so we.
Although, I mean, the question is if 7 repetitions are enough to build up a decent predictive context, right? If that's the case, then I guess having 16 or 8 in a row shouldn't matter too much for the contextual modulation. It is, however, that you can observe more oddballs in a shorter experiment duration, which could be actually beneficial to exclude these long-term changes from the analysis, because they are somehow overlaying this purely contextual driven modulation, and we have the long-term modulation, so they're somewhat intermingled in our experiments. And the question is,
my understanding is that the strength of oddball responses is like inversely proportional to their probability up to very low probabilities. I think Jerome presented that earlier. If maybe that's not true in this context, but I would hesitate to just push up on the oddball frequency because of that.
Same,
I see.
yes. That's also yeah, it's a result that we have in the archive paper.
Ah,
I mean,
okay.
it's possible. So if we change the rate, your statistic might need to be different.
Hmm. Yeah, okay.
I think the way
Yeah,
to
I
get
wasn't aware of
more, I think the way to get more statistical power is to have fewer oddball identities, right?
that.
And then you can have the same rate of oddballs, but then just have more presentations of each identity,
Right.
which I think is basically what you were, I think, you were saying earlier that like the 45-degree wasn't really adding anything. And I sort of, my intuition, which I've been sort of commenting on in the comments, I really think that the cleanest comparison is to be able to compare stimuli both when they're standard to when they're oddball. And that means that for every oddball, you need to have a block where it's the standard.
Right.
Otherwise you don't have data for that you don't have complete data for that case. And that would advocate for having fewer stimulus identities, maybe just 2, and just have a crossover where a stimulus is standard for a while, and then it's an oddball in the other standard block.
Right. Yes, I think that's a very interesting design. It also somehow enables us to do the similar analysis that was done in the Fuotashi 2024 Nature paper in Sonja Hofer's lab, where they do not only vary the predictive context, but also the stimulus of the deviant. And if one varies both, then can one actually check if the responses during deviant are driven by only one particular stimulus or if it's driven by predictive context. So I think it's very nice to have both of these things. Having 2 different deviants, but also having switching the deviant standard. Yeah, I mean, if for example, if we would omit the omission and static oddballs, then we could essentially have another oddball block where we switch those, and we have the same duration of the experiment.
Let me share my screen. Is that okay, Lucas?
You have to, yeah, yes, sure.
Okay. Can you see the slide?
Yeah.
I would like to propose that what we do is follow this design where we have 3 orientation tuning block that will be 30 trials long each, so fewer repeats for each block. And then in odd block 1, we present the vertical as a standard, and then the 90 degrees as the oddball, as we said, as well as a 45 and an omission. So we remove the alt, and we do 30 trials, so that's going to shrink it a little bit. And then in oddball block 2, we switch with the 90 degrees is now the standard, the 0 is the oddball, and we keep the 45 unaffected. I think between reducing the number of trials, that should fit, and removing the number of oddballs, that should fit within our budget in time, especially for SLAP2 for glue sniffer imaging, which is stable throughout the experiment. For calcium, we might have to think hard there, but I think that would work. Does that make sense, Lucas? Or?
I think that's a good idea. The only thing is, I was wondering how we control for plasticity changes that could occur during oddball block 1, that then affect responses to that orientation in the oddball block 2, so that essentially differences between that orientation being redundant or a deviant oddball like a standard or deviant, if that could be driven by changes in the plasticity. So
You mean the
then
45
another
degrees,
idea,
for instance?
for instance, exactly. So I was just wondering, how about we leave out the second orientation one and we merge the oddball box, but we have the difference, like the standard and deviant, switch in, let's say, blocks of 3 minutes or so, where we switch them, but they are essentially intermingled so that we do not have a bias of plasticity only affecting one of the oddball blocks, because in the end we want to compare the conditions. So comparing the two oddball blocks, and if one can be subject to plasticity but the other is not, I'm just wondering if that could be.
But I think this is closer to Jordan's lab design. I think to support doing that, we'll need to analyze the very beginning of the oddball block of the experiment we've done, right? To see how fast does the the redundant response decreases. Do you see what I mean?
Yeah. It's just I think just because of the high number of standards that we have, I think in Jordan's experiment it wasn't such a big issue, maybe because probably the oddball blocks were just shorter. And I mean, here we already saw quite a difference in the control, like orientation 1 versus orientation 2, with the slightly longer oddball block. So I mean, here it would be 75%, right, of the duration of the one we used right now.
It'll be shorter. Yeah.
But it's still, I mean, 75% is probably still sufficient to induce plasticity. I would expect, and then it has some time to, to be expressed, and then in oddball block 2, there could be actually quite a strong difference just due to having experienced the oddball block 1. That's just what I'm afraid of when having this, essentially this confounder of it's a different context in which the stimulus is shown, of course, but it also some plasticity might have had occurred. And disentangling these two effects might be very tricky.
Kareem, you have some. Kareem, another question.
Yeah, I just had actually a comment more so. So I happen to believe in using this minimum number of trials to probe a given system, because the adaptation could be really wrestling. We could be wrestling against adaptation. So if we have, and given that what we are trying to detect is this response to the odd stimuli, what if we consider a small number of trials at the beginning in orientation 1 blocks or 2 blocks or any of the orientation blocks, where we determine the extent of adaptation that happens to repetition of the same stimulus, and have that aside as a way to normalize or to subtract off from whatever we're actually looking at. So if adaptation is not the main goal here, it's a way to ensure that what we're observing in the oddball blocks is not confounded by the fact that you have ongoing plasticity and everything else that Lucas has hinted at.
Are you suggesting analysis or?
No, it's actually part of the stimulus design, since we're discussing stimulus design here and the order of presentation and what to include, what to exclude, number of trials in each. I think it might be beneficial to run a small number of trials where we detect or we associate a profile of adaptation for each of the ROIs we're interested in, or each of the angles that we are going to be using within each orientation block, to see who adapts quicker than who doesn't care.
See.
You know, that sort of thing. This is just part of the experiment itself, not the analysis.
So you would repeat the same orientation, say 10 times, For each orientation.
Correct. Correct. To just test the extent to which repeating the same input multiple times within a particular span of time changes the response properties that we are after. If we have a good handle on that, then we would know, okay, later on when we present an oddball, now knowing the history that this particular ROI has seen this type of inputs X number of times in the past X number of minutes, then what we are going to interpret is legit or not.
I think that's a very interesting idea. The only issue I see is that again we have this problem of statistics that in order to kind of make sure that what we see is not, let's say, a particular instance, but it's really a systematic effect. We would need to do this a couple of times per stimulus, and I'm wondering how much time we would have to allocate there. One point. It could be that let's say something I was also asking last time. If it would make sense to actually have two experimental designs. One essentially targeting the modulation part, so trying to kind of minimize the effect that learning could have in the comparisons, and then one where we actually focus more on the learning, so on the comparison between orientation 1 and orientation after oddball. If that would make sense, because in that one we might not necessarily need to switch the orientations during the oddball. Whereas for the modulation, if we're interested in the modulation, contextual modulation, then definitely would be nice to change the orientation there. Would something speak against changing the standard, let's say, in shorter blocks? Because then we have essentially that there might be plasticity happening, but it's happening consistently, at least between the two oddball blocks as we proceed through that part of the experiment. Yeah, if the target is to compare oddball condition 1 and oddball condition 2.
I think it would be helpful if we do some analysis that look at our existing data to see when you present the same stimulus, the standard condition over and over from the start of the oddball block. Because I think some of the analysis Karimi is suggesting can be done with the existing data, but not entirely. But just look at when the oddballs start, the strength of the response, and see how it decreases over the next few trials. And when an oddball is done, the next trial, when the standard oddball comes back, what happens just after that? I feel like this could be done. I think that would influence that design very much.
I agree. I think the existing data can help sort this out before we, decide to change the stimulus design from the current setup.
Yeah.
Well,
I agree. Yeah.
And specifically, I think that, if you want to see how stimuli adapt, enforcing that you get a certain number of presentations of the standard, well, it doesn't fully address your point, Kareem, but it at least you would get that adaptation information for the standards in each standard block, which I think is useful. I am more concerned that the orientation 1 block is going to have very different responses than the orientation 2 block, just because if the animal's been sitting in the dark and then we suddenly turn on the screen in order to start the orientation 1 block, it's just going to be, we see very big responses when we first start presenting stimuli to the animal, and then it levels out. So I would advocate that we habituate the animal just with essentially, we start off by taking like structural images and stuff like that when we stick the animal under the rig. I think maybe we should just show orientation blocks during setup in order to adapt or habituate or whatever the animal during that particular bit of the experiment.
Yeah, my student used to call this a warm-up block.
Yeah.
Where the warm-up block basically shows samples here and there from what you're actually going to show, but not really the science part is not going to include that part of the analysis. Yeah.
And it won't slow down the experiment at all to do that. It just means turning the screen on earlier.
Agree.
Okay. So I propose that I make slides, a variant of these slides on the screen with like specific details and the numbers for everything so that it's very clear. And then I put this on the forum and we continue the conversation there. If Nicholas, you were planning to present next week, right?
Yes.
Do you think you could look a little bit at the onset of the block to see how the response evolves, or is that something that you think is possible?
Yeah, I think it's possible. I think actually Yuji has begun some analysis of that, where she was doing at least trying to apply DPCA to the oddball block to look at how responses evolve over time. But yeah, I can certainly look at that and do a complementary analysis to what Yuji is doing.
Is Yuji can she hear?
I believe she is here. Yes.
I don't know if she can speak to that. Oh, maybe not. Not real time. Okay.
Maybe one point. Oh, go ahead.
So you're referring to okay, so the issue here is, do ROIs exhibit, say, transient adaptation?
That's right.
And
at the onset of the block.
At the onset of the oddball block. And so, and we want to look at the impact of the oddball block on the responsiveness of the ROI, so these to the deviant angle versus the standard angle. And by adaptation, we're referring to the fact that the ROI is decreasing its responsiveness to either the deviant or the standard stimuli because it's continually receiving that stimuli. And we want to see by how much are these ROIs adapting. But to me, adaptation in this case seems like not a confounding factor. It seems like if yeah.
It could be part of the learning that occurs, yes. It could be part of the learning, but yes, please, Lucas.
I think what you mean by just to get this clear, adaptation is that the contextual modulation, so you have the same orientation for a lot of times that can depress the response of the standard, versus learning modulated, let's say, so that you have over longer times the responses adapt. So what are we? I would just follow this. What are we referring to?
You're saying that there are two forms of adaptation, one that is the consequence of learning and one that is something else.
Yeah, like the contextual, like that depends on, the last second or 10 seconds of stimulation, like this predictive context.
Nice. So that would be transient adaptation, and that'll be transient. But we're trying to disentangle that from adaptation that is longer term.
Right. That's how I understood it, but I don't know if we are all referring to the same thing.
Let me clarify a little bit, because we have done experiments to just answer this specific question. The adaptation, if it's non-context specific is going to happen no matter what order, what time you play the stimulus to the neurons, right? So it's just the fact that this is the same input. It's repeated multiple times, constantly depolarizes the cells. The cells are going to adapt to it. Now, what we're talking about here is, what if this is ongoing? We know it's gonna happen. Now I'm presenting a deviant stimulus, right? And now I'm asking the question, are the cells detecting that and changing the response properties to the fact that I am now presenting this thing? Now the question is, which state the neurons are coming from? Are they coming from an adapted state, or are they coming from just a completely blank slate where they had no idea what the history was of what was presented to them? So the current experimental design, the data that was collected, is actually helpful to try to address at least that these two might be two distinct things, and we have to account for them moving forward. I hope that clarifies things a little bit.
Wouldn't we expect the orientation tuning block in the pre-block or the directional tuning block to induce some transient adaptation?
Yeah, I mean, it might depend on the number of repetitions. So that's why I brought this idea that we should not be using more trials than needed. Yes, we use more trials because, we want to get a larger sample and get some nice tuning characteristics. But the price we pay here is that doing so might make certain ROIs, or all of the ROIs, or none of the ROIs, adapt in different ways. That's all I'm saying. So there's a price to pay.
Okay, it's 10:05. I think I'm gonna make these slides with this detailed design. I think it might be worth it we try a first modification. And if needed, we could consider another variant, but I think there's value in moving forward, especially if we can do experiments already. And so I'm going to make this detailed proposal, and then everybody can weigh in. And if there's bandwidth on the rig to execute it, and we have general agreements on the numbers, we can run it and then share the data. And so then if we need to make another variant later on, we can. And it will be helpful. So next week, we can discuss this detailed design if needed. But if Nicholas, you're planning to present, if you could include some analysis of repeat against the number of repeats, that will be helpful of adaptation, or like the immediate effect of the first and second and third repeat of the same stimulus.
Yes, so I can do follow up Lucas's statistical power analysis with one of my own that looks
Yes.
at R1 specifically, and I can also look at adaptation and
Yes.
maybe give a first go at disentangling fast adaptation from learning-induced adaptation.
And we'll see offline if UG can join in that, because you said she has some analysis. Okay. We might present, I'm going to see with Severin if we're ready to present the NeuroPixel targeting scheme that we are working on. Okay. Anything else we should discuss today?
Just one small thing. I was already doing an analysis where I split the outboard block in half and trying to see if there are differences between the first half and the second half to assess a bit these long-term changes that evolve or that already happened during the outboard block. Would that be something useful to look at as well? To address this question: how much can the outboard responses vary already due to long-term changes?
I think it could, although I might argue what the question we're trying to answer is about the quick effect, not because the outboard block is 30 minutes long. So cutting in half is not going to answer that question. Do you agree, or?
I mean, Exactly. No, it addresses the other problem of the intermixture of contextual modulation and long-term changes, which was also, yeah, because we have both effects occurring. And I would just like to see how strongly do we see a change in oddball responses between first and second half to see how strong that effect is, essentially. Because
Okay.
it will be important if we want to compare oddball 1 and oddball block 2 conditions. If there is plasticity, it will be hard to interpret what causes them.
Okay, so if you have that analysis, please share it on the forum and we can discuss it. Yeah.
Mhm.
Okay. Anything else? It was fantastic, Lucas. Thanks for so much work.
You're welcome.
If there are no more questions, I think we can split apart. Thank you.